a problem I see is that people work on the symptoms and not the cause. And that's something we've got to work on. Like, microplastics, that's really the symptom. The cause is the plastics and when we're doing them. California has some of the worst problems. They've got the trash vortex because they take for years, they've taken their trash, just dumped it in the ocean. Well, that's coming to bite everybody. Now, the next big question is, do we need to just go in there and clean it up? They've got those big machines now, those boats that skim the top to get that stuff off, and that's a great start. What about all the stuff on the bottom? Well, now you have organisms making that as their home. Is that good or bad that we just go in there and tear it all out? People like civil engineers with no real chemistry background, no microbiology background, and I'm seeing the results of the things they design and the problems that comes with that. I've got 3 kids, all my 3 children. They're all, one's finishing up her PhD in neuroscience, one's a youth minister in Houston, the other one's a computer security consultant. They're all doing pretty well. My wife, background's in education, she writes curriculum here at a local church. And then I'm a chemist. I love camping. I love to go backpacking. I like to go way back in the backcountry. I sort of get mad at people when I see the trash they leave behind. That's one of my pet peeves everywhere. So, yeah, that's one thing that my family has to put up with. But it's for the good, because now, especially now, I guess it takes years just to grow up and to see the problems and where they come from. And we may really need to. It's a short time bad for, the mollusks and stuff that are living there, but probably long-term good for the ocean. And same thing for other technologies that we use. Like people are liking RO water, even though it's not safe to drink, but nobody wants to deal with the waste. And the waste kills things. There's already books out on the toxicity. If you put the waste and try to water a tree, well, you'll kill the tree, you'll kill any vegetation. You put it directly into the ocean. Well, they're having problems in California with these desalination plants now because we're getting the salinity is out of whack. Well, maybe we need to rethink these things. Maybe there's something else we really need to do. Personally, I've been in the water industry here in Abilene for about 30 years, and I was in R&D for probably another 10 years before that. When I was at the University of Texas, I worked for a guy named Dr. J.J. Legowski, so I got in the lab pretty soon. I started off, this is right when all the microcomputers started. I was the first one, or the University of Texas was the first one to actually get those in the classroom. So I still remember the CompuColors, which you guys probably don't remember. So that was the Apple IIs, which nobody remembers those. The TRS-80s, which back then the TRS-80s was actually pretty good. As an undergraduate, I got a lot of experience in the lab with just instrumentation and just a bunch of different projects. And that's just helped me professionally, because everywhere I go, I've done a pretty good job. Probably my first fun professional job was probably at CUNO, because I was working on specific problems they were working on with the amnesty programs they had to try to clean up the sound in other industries. So it was heavy metal removal from industrial waste and food products stuff. So we made a couple of grades on that. And that was fun because besides being in the lab, the way they did it at CUNO, I also had to go to the pilot plant. So I'd help them get to the pilot plant to get that going, and then also got to see it in the factory where they actually made it. Mm-hmm. And when I came to Abilene for grad school and got this job and just been here ever since, wasn't actually planning on staying here this long, but we're not going to leave at this point. There's so many things to learn, and coming with a research background, now just focusing only on water, not on other things, I'm seeing how bad the research has been. Professionally, I've got a BS in chemistry. I've got patents. I've got 3 A licenses. There's only a handful of us. My licenses are in water, wastewater, and laboratory. They're all A licenses. Last time I checked, I think there was 41 of us nationwide. There's not with that mix. Most people don't want to deal with the laboratory side. Well, that's probably the most fun side. And as I've been here in Abilene, I focused more on what's going on in our watershed because I'm responsible for that. And I'm seeing these things. We don't need to be doing that. So now you start speaking up. Of course, you always make somebody mad, but they can deal with it. They can deal with it. It's funny because, when they have a problem, they want you there to solve it. We really need more lab techs and really need more space because there's a lot more things that need to be done because there's not much research really being done on um, really in both water and wastewater on how do you dispose of stuff, what all is really in the water. And there's so many things that I have learned.
Well, Mike, could you, and I'm thinking about, some of the people that aren't from Abilene. Could you just tell us just a little bit about what you do on a day-to-day routine?
Yeah, my official title, I'm Quality Control Division Manager. So we actually do quality control on all the plants, on their operations. We check their raw materials. We check their daily processes, and we also check their products. So make sure everything looks up. I'm also responsible for the watershed. So we go to the lakes and creeks on a routine basis, and also for the distribution and collection system. So I have one or two of my guys, sometimes 4 people out in the field every day collecting samples, especially like the bacteria. That's the number one thing that's checked daily, and then the chemical composition of the different plants. So I deal with collection systems, distribution system, laboratory, and industrial waste is under me also. I've got an industrial waste officer. His job is to monitor all the industries, and we do that. We have these samplers that we can put in the sewers and hide, so we can take samples anytime, day or night, because it's all computer-based, computers on them to take it. And I also have backflow under me, and that's the guy who has to make sure that, especially people like irrigations and wells and industries that draw a lot of water, they have to have a backflow prevention device in there so that some of their muck doesn't get pushed back into the system. Irrigation systems like for a lawn, those are some of the ones you have to worry about the most because people fertilize. And when they turn that water off, that last bit is sucked in, you can get high nitrates. We have found some places with high nitrates. And it's taken now. I'm supposed to be worried about people's health. That's a health issue when you have high nitrates. So we're starting that up again. You'll probably start seeing things within a month. We're getting a website up and some information flyers getting ready to come out. And then after that, we will hit the people that we know have the irrigation systems and also some of the wells. If there's a problem at someone's house, I'll usually get called to go try to figure out what that is. So in a nutshell, that's it. And then the stuff in the lab we run right now is the GCMS.
And you said GCMS. Now, what is that?
Gas chromatography mass spectroscopy. That's what's used for volatiles well, mostly we use it just for organic volatiles, semi-volatiles. You can do it for non-volatiles, soils. Like say for a trihalomethanes, that's a disinfection byproduct. We'll take a 50 ml sample, put it in a vial, put it on the GCMS, and then it'll suck up some sample. It'll start purging everything with helium, so all the volatiles will come out, and that's called an absorber. And then after about 15 minutes, that stops, and then we heat the absorber off, and that goes to the column. The column on the GC gas chromatograph, that'll start separating out all of the different compounds that are in there. You may have 90 compounds on there. So then you got to go down individually and break them all down. Now with the computer can recognize them all. So once you have a calibration, work on the computer, then you just got to compare them. The bad thing on the computer's recognition is it does it from neat materials. And we don't deal with neat materials. We're dealing with whatever we have in the environment. So it helps a whole lot, but you got to go and separate a little bit of things out. We have an ICP-MS is the same thing, only that's just looking for metals. So it does the same thing.
I was thinking about some of that. You gave some interesting stories about things that everyday people can be worried about with their water. I mean, you mentioned already, for example, the fertilizer getting sucked up by like an irrigation or a sprinkler system. But what are some other things that people are doing, probably without even thinking about it, that's very dangerous to our water supply?
Yeah. Well, number one, they're doing at home a lot is they're using water from a hot water heater to cook with, or who knows what all. Never do that. Hot water heater or a water heater, it's made of metal. So as you heat it up, it's going to start dissolving some of that metal, and that metal is going to be in your water heater, your water tank.
Mhm.
And it's really easy to see if there's a little knob on the bottom. Just go and open it just for a second. And if it's not clear, you need to clean out your water tank. Most people need to do it about twice a year. That's one right there. Another one on drinking water. If you feel like it has tastes like too much chlorine in it, which in Abilene we don't use chlorine, fill a pitcher up and just put it in the refrigerator for an hour or two. It'll cool down. A lot of that will dissipate off, but it'll kill all the microorganisms in there. So that makes that safe to drink. And that's much better than putting it through a filter. When you put it through a filter, usually you end up having a carbon filter in there. Carbon filter grows bacteria. It does take out the chlorine and chlorine compounds, but now you've got the problem that the chlorine's there to get rid of is the bacteria. And then if you have a deionizer, well, you shouldn't really use those anyway because that's going to pick up heavy metals. Julia was talking about bottled water, but she's only done part of it. The other part of it, bottled water is not safe to drink. Besides the plastics, it's acidic and it has bacteria. See, it's not bottled as water, it's bottled under a beverage, so they don't have to meet the minimum requirements for drinking water.
Oh,
And
no.
if you look in any bottled water, I haven't seen one, well, that's not true. Evian is the only one that meets minimum standards, but I haven't done some of the organics on it. Any of them, though, you'll see they add, usually it's calcium chloride and sodium carbonate or sodium bicarbonate. They've got that backwards. You want the calcium carbonate, that's the calcium that your body uses.
Mm-hmm.
Calcium chloride is just hardness. It doesn't do anything for anybody, but they do that for taste. And what the problem is, it's over purified. So when they open up the bottle, it absorbs carbon dioxide from the air. That turns to carbonic acid. And it's instant. It's just a couple of minutes. So there's no way around that.
What are some other things people are doing? I think you mentioned last time that there were people that were maybe pouring things in their sink that they shouldn't pour down, or.
And also, if you have a stainless steel or a steel sink, anything that's acid is not good because it's going to take a part of that with it. And if it's knocked out at the plant, it'll end up in the sludge, then that's normally going to be okay because that's going to go back more towards nature. But if it passes through the plants, then it goes to the water streams, and someone's going to have to deal with it somewhere. A fertilizer is another one not to do it because it's high in nitrates and high in phosphorus. And some of that will pass through the plants because the wastewater plants can only remove so much. And then once that hits the streams, you'll get quick growth of the plants, which choke everything out. And it uses up the oxygen, especially if there's any algae, and that kills the aquatic life. Leave fire hydrants alone. I've seen people trying to steal water from a fire hydrant. And people don't understand, fire hydrants, underneath a fire hydrant, there's a vault. And there's a metal pipe that goes from the fire hydrant to the vault. So when you open a fire hydrant, the first usually 500 gallons is going to be sort of an orangey color. You're never going to drink that. The only ones who deal with that are us from firefighters. So that's not in the water system. That's sometimes, because people freak out, I know, sometimes when they see that. One thing is, this is Chief Seattle said this. He's the chief up in Washington, where Seattle's named after him. And I live by it, and I think it's probably the best thing. And his quote that I like is, "Man does not weave the web of life. He is just a strand in the web of life. So anything we do to that web, we do to ourselves." And I think everyone needs to just think about that. Especially in our daily actions, there's things that we can do. Sometimes, it may take us a minute or two to pick that thing off the ground, or not pour oil somewhere, take it to a recycling center, or the things we can recycle. I'm a big recycler of all sorts of stuff. In fact, I'll send you a picture of this thing I made. I made a workbench in my garage. It's all out of pallet parts, with the exception of some of the fasteners and the wheels. I gotta send you a picture. It works great. I love it. It's heavy duty. Those are things that people are going to throw away. And there's a lot of stuff like that we can reuse. And we need to be pushing. We need to be finding ways to recycle.